Okay, friends, welcome to day 2 of calculus. And it's actually still pre-calculus because we're going to be reviewing fractions, rationalizing, and slope. So stay tuned. I'm going to walk you through this slide deck in case I am not with you. So anyway, here are the skills that you want to be able to do today. Are you able to simplify that complex fraction? Can you simplify that complex fraction? Can you rationalize that denominator? And can you determine a linear equation that passes through the point 49 and goes through the point 6 comma negative 11. So that's what we're going to talk about. So first off, you're going to be asked to simplify this fraction. There's a couple of ways of doing it. One would be simply to, take this and go 3/4 divided by 5/3. And that's a great start. And then we could go 3/4 multiplied by 3/5. So we flip the fraction and multiply by the reciprocal. I'm going to ask you to explain why do we flip that? Why do we flip it and why do we change the multiplication? That's an important thing. So you could take it from there, and that looks to me like 9/20. Okay, and then I've asked you to do this in 2 ways. Another way you could do it is think, well, what could you multiply this thing by to remove the complex fraction? So I'm going to multiply the bottom by 3/5, and in doing that, that would make the denominator 1, and on top, I would have 5/3. I want you to take note of something. Do you notice that this guy right here, this guy right here, 3/4 times 5/3? Oops. Oh, geez, I'm making silly mistakes. Okay, good grief. Let's see, I don't know how to erase this. Shoot! This guy right here should be 3/5 here, shouldn't it? Okay, so excuse me, what a great start to this explanation. So notice that this guy here and this guy here are the same. And if you're wondering why do we change division to multiplication and flip the second, because that's exactly what we did to simplify that fraction. So there you go, 9/20, and there you be. Now we're going to look at this guy. How would you simplify this one? Well, again, let's think about what's making it a fraction. It's not the 7, it's not the 3, it's not the 3, it's the x. So I'm going to multiply top and bottom of this little cutie by x, top and bottom, because I'm really just multiplying by 1, and then I'm going to clean things up from there. So I'd end up having 3 plus 3x over 7x, which is what we have there. And then in this next guy, so in both of these would be correct. They're both equivalent fractions. There's lots of ways of leaving things. Okay, and let's see over here. This one's certainly more complicated. Again, this time what we're going to want to do is to notice what's making this complex. The worst thing here is this little guy here. So we're going to multiply top and bottom by x plus 1 and x plus 1, and we're going to expand that all out. And then we're going to multiply top and bottom by x. So we'll do both of those things. And when we do that, it simplifies to this. You don't need to factor the top or expand the top. Either way would be fine. So I would probably not expand the top there, probably. But if I did, both would be fine. Either would be okay. So then what's an irrational number? So you should be able to define that. And an irrational number is a number whose decimal does not stop or repeat. So it has a pattern. It has an endless string of digits with no patterns and no repeating. If we multiply root 5 by root 5, that's going to be the square root of 25, which is equal to 5. Or put another way, if you multiply root 5 by root 5, you're just going to get 5. Okay, and so you're going to be asked in this next little section to rationalize the denominator. So if we added these two fractions together, we'd have 4 over root 5. And I know before we answer that, just think about this. If I had a little piece of pie here and I had, say, 1/4 of it, we could all draw that really easily. That would be no problem to do. I have 4 parts and I want 1/4 of it. But in this one, this is asking me to have 4 parts of root 5ths. So I don't really know how to draw root 5ths all that accurately. So what I'm going to do is rationalize the denominator and make the denominator a rational number. So I'm going to multiply top and bottom by root 5, which is going to give me 4 root 5 out of 5. And so now I have a much easier denominator to work with. So there you go. Let's make sure. So here's another move that I want you to notice. There's something to notice here when you multiply this out. There is a pattern. This, believe it or not, creates a difference of squares in a weird way. That could be considered a perfect square. And if you see root 3 times root 3 as 3, you could call that, it's not a perfect square, but we can still take the square root of that. And 3 is a square if the square roots are root 3 and root 3. So notice that. This is called, this piece here is the conjugate to this guy. The conjugate, and this guy here is the conjugate of this guy. All right. So let's go back here and clear that out. So then if we said rationalize the denominator, we want to make this a rational number. We're going to multiply top and bottom by root x. And when we do that, you're going to end up getting root x over x. So we're good. And this guy, more challenging. If we want to rationalize this one, notice that if we do root x and root x here, you might think that rationalizes the denominator, but what you're going to end up having is that, which is okay. But then on the bottom, you're going to end up having x minus 2 root x, which is not rationalized. So that did not work. If you can see, what we're going to do though is we're going to multiply top and bottom by the conjugate. And when we do this, root x times root x is x. Negative 2 times 2 is negative 4 on the top, takes care of itself. So that sucker has been rationalized, which means that the denominator has rational terms in it or rational numbers in it. Okay, this one is rationalized the denominator. It's going to be really simple or similar. We're going to multiply top and bottom by the conjugate of this sucker. And the conjugate of that guy is root x plus 3 plus root x minus 3. And when we do that, believe it or not, it all simplifies to 6 on the bottom and the business up top. Notice I left it in a couple different ways. Both would be all right as ways to leave that. Okay, getting more complicated again. Rationalize the denominator. Well, oh boy, this one's tricky. I am inclined right now to get rid of the fraction first. So I'm going to do this first. So I'm going to go top and bottom by root x. This is not rationalizing the denominator. In fact, some people might say that the denominator is rationalized. So perhaps I should word that better. But basically what we're going to do is top and bottom by root x, which cleans it up to 1 plus 3 root x. And then on the bottom, we're going to have x minus root x plus 3 root x. Then notice this. If I multiply the top and the bottom by root x, what's going to happen is I'm going to have that root x is going to cancel and give me a 3x, and that one's going to give me an x times x for x squared. And you can see that all I need to do there to rationalize is that little cutie there. I do not need to use the conjugate there because there's just a root x in both those terms. In fact, some people might factor out a root x there and then multiply by root x. Okay, so looks like we're getting into a bit of review of some grade 9, 10 here. Write the equation of a line that passes through the points. So this is probably best done by sketching it out as best you can. So I'm going to plot that point at negative 4, 10. Okay, and then at 4, negative 4. So we're trying to find that equation right there. And so what I'm going to do to find the slope, m we know equals y2 minus y1 over x2 minus x1. Okay, so we're going to start off by just filling that out. We're going to go negative 4 subtract 10, and we're going to go 4 subtract negative 4. Okay, so that's going to be negative 14 over 8. Okay, and which is going to turn in, I'm going to simplify that to negative 7 over 4. So if I'm writing the equation of the line's going to be y equals negative 7 over 4x plus the b value. And here's the thing. If this line goes through either of these points, then if I put negative 4 in for x, then y has to equal 10, and I can use that to solve for b, and hopefully that's what we did, and that's what we did do. Okay, so once again, once you have the slope, all you have to do is put the negative 4 in for x, which returns 10. Otherwise, the line doesn't go through that coordinate. Okay, and finally, write the equation of the line that passes through the point 37 and is perpendicular. Okay, so I mean, this would be nice to do on Desmos, but for right now, let's just do it right here. We're going to go, there's my line. If something's perpendicular to that, that means that it's at right angles. And we know that the slope perpendicular to that one is the negative reciprocal. So that would mean that the perpendicular slope would be y equals negative 1/2 x plus 7. And once again, if you take the negative 3 and put it in for x, it has to excuse me. You saw that, silly. That's not 7. That's b. We don't know what that value is. Okay, write the equation. Okay, so we put negative 3 in for x and 7 in for y, and that will help us find the b value. If I'm on my A game, hopefully I am, I should be able to click on that and take a look at Desmos. Okay, and so that's the first one. Here's the second one. So here's the initial guy, and let's just play around with this for a second. Let's lose that one, and let's try to find some slopes that might be perpendicular. Y equals 2x plus 10. Well, that's not perpendicular. I probably need to add a negative. Okay, so now it's going the right way, but I need to get the right angle on that. And so by maybe some trial and error and exploring this, we'd end up trying different values. Okay, so that's at 90 degrees. It sure is. Let's just change this up a little bit. Let's make this 5/6. So that would mean this guy here would have to be 6/5. And we can see that that's at right angles again. So the way you find a perpendicular slope is take the original slope and create the negative reciprocal. And just to make sure you are clear on that, if I put a negative there and let's put an 11 up here, okay, well, what I'm going to need to do here is make the negative. So if it's negative 11/6, I have to make it positive. And now I need to make the 11 on the bottom. And once again, we're at 90 degrees. Okay, so hope that helped. And there's plenty of practice for you to take a look at. And I hope that helps you